Well, hi, I'm Hud Freeze, and I'm going to tell you why we play these CDG name games all the time, because I'm sure for a lot of you that has to be a real pain. So let's go back and see if we can give you a little history on CDG. Well, in 1980, Dr. Yakin first recognized these sweet young ladies here, these twins, who had a funny kind of deficiency in something called sialic acid. And it had affected a molecule called transferrin, and that's a iron-carrying protein in the blood. And it was unusual. And as you can see, the picture down below is them a good number of years later. But you know, this started something, because then someone else, a woman named Helena Stibler, came along and found that there were also patients. So this was interesting because it involves something called glycosylation. And that's what people who are called glycobiologists study. And so what is...
What's the matter, Sal? Not up on your glycobiology?
Well, there are a lot of people who weren't up on their glycobiology, especially back in those days. In fact, if you had to consider, there were probably several hundred glycobiologists, and those glycobiologists kind of stuck to themselves. They didn't get out much. It's not part of a normal medical curriculum, and it's not even oftentimes part of a general science curriculum. But in fact, what we need to do is we need to realize that there can be a CDG ecosystem. And what do I mean by that? Well, of course, you know that physicians and scientists talk to each other, but they probably don't do it as much as they should, and not as often as they should. Well, because glycobiology was really not part of physicians and most basic scientist training, that interaction didn't occur quite often enough. And of course, the most important component of this are the families. And the families, of course, then mostly deal with the physicians as their primary contact when medical problems develop. But because there wasn't a lot of information back in the mid-90s that most physicians had access to, it turned out that many of the families would actually reach out to basic glycobiologists like myself, and we became involved. Now, even though many of us didn't have medical degrees, we wanted to help. We wanted to do what we could. And so we felt we had to offer something back to the families. And when we could do that, that provided a little bit of satisfaction for us, and also helped the families with their struggle. So as we went along, we had to say to ourselves, well, who really is the CDG audience, and what do they want? Well, scientists, that's the part I come from, we're involved in basic research, mostly glycobiologists, and we believe in these exacting and precise descriptions of all these sugar chains. We're real purists, and we're dedicated to the craft. Well, we want to be the scientific authorities, and I think for the most part, we feel we know that field pretty well. But we're not by ourselves, because physicians are part of this mix also. They're always overloaded. They're trying to keep up, never have enough time. They're overloaded with patients. They want to do the best job they can. So please, scientists, glycobiologists, please make this organization about all this glycosylation. Please make it simple, make it easy to follow for us. And families just say, please, make it simple. Don't we have enough to handle? So we'd like to know who our closest scientific and medical relatives are in CDGs, as we try to find out who we are and how best to take care of our kids. And above all of you guys, please find some treatments, whatever that takes. Well, what it takes is all of us working together in the CDG ecosystem. And so, the way we think it works, and I think this is probably a good illustration, is Larry Tabak, who now is the interim director of the National Institutes of Health put this slide together. He says, you know, this is the way we think it works, that the basic laboratory research gives rise to translational research, and that goes into the clinic, and then you come up with something from there, and population research then altogether improves public health. Well, he had a second slide. It's not the way it really works. It's a circle. All of us are contributing to each other all the time. The basic laboratory research can sometimes be used as a marker in clinical trials. Population-based research in clinical trials gives us a bigger picture of the way we're interacting with each other. And patient-oriented clinical research, I don't have to tell you about that as families. You want nothing more than to have treatments. Well, this is the way we're going to do it, but we've all got to work together. And so if you look at the larger biomedical ecosystem, I'm going to call this, we have scientists here who are talking and interacting with physicians. And of course, as I pointed out earlier, both of us are interacting with CDG families. But, there are other family groups out there who may also be knowledgeable or affected by glycosylation. And they don't necessarily know that they're CDGs. They may have characteristics. And as we try to organize and characterize all the things that go into glycosylation, they may be involved. So not only that, but as we try to look at all speaking the same language, we have to have information trackers out there who keep track of all the papers and the data and all the genetic disorders. And these are, I'm going to call them information trackers, not like the National Center for Biotechnology Information, OMIM, which is a big database that categorizes all of the different rare disorders. And so when we look at this, we realize that if we're going to make progress, we're going to try to make everybody happy. This is going to be something that requires all of us speaking the same language. So let's give a little history of how some of the language started. So if you think about this, how many CDGs are there? Well, right now, as I'll show in a minute here, they're probably close to 170. But historically, we had what we called two groups, group 1 and group 2. Roman numerals, okay, just like you learned in school, 1 and 2. But then it turned out that Dr. Sibler says, well, I have a new type, and I'm going to call it type 3. Someone else came along and said, well, I think I have a new type, and I'm going to call it type 4. Yet one more came along, and now we are at type 5. Well, if you look at that, and now you figure out what year are we in, we're in MMXXII. I'll bet most of you, unless you are a Greek and Roman scholar of the old days, you probably don't naturally think in terms of those kinds of numbers. And as you see, this is our chart of number of glycosylation disorders that we have now. And, if you start thinking about different numbers and how we could express those, it's going to get real cumbersome to try to look at all of these things and think about it in Roman numerals. That's just not going to happen very much. So we need to come up with a better way to communicate these things. So there was even one very well-known glycobiologist who proposed carrying on this CDG nomenclature, but to do it in a way with Roman numerals. Fortunately, that didn't succeed. But what did happen is that we were able to define what a CDG is. And a CDG is a human pathological disorder where the genetic alteration changes glycosylation. That's the act of putting on sugars onto proteins and lipids in one or more proteins or those lipids. So that can include various kinds of enzymes and sugars, and it requires proper pH, metal ions, and lots of different functions that go into making glycosylation happen. We call that glycosylation homeostasis. So now, even though we're a little bit below 170, some things that are coming out in the very near future are going to show we're at probably 170. So in 1999, a group of us were together in Leuven to be able to say, we got to grab hold of these Roman numerals and not let them get away from us. And so at that meeting, we came up with an idea. And that idea would be to define two groups, group 1 and group 2. And these were at the time when there were only N-linked glycosylation disorders that were considered. And that's evolved tremendously since that time. And so we would divide those two into, as you can see up here, CDG1. So that would be a group 1. There is a group 2 down here. They had a different pattern of transferrin identification. And we decided that at that time that there would be types, not subtypes, types that would be called type 1A, 1B, 1C. And so that's the nomenclature that many people may be familiar with. But because there was also type 2, we could do a type 2A, 2B, and so on. If we didn't know what the genetic defect was, we just called it type X. And so you can see these over here. So, you know, that worked for quite a while. But when you now, in retrospect, think about 170 disorders, we're going to run out of alphabet real quick. And so how can we handle this? And of course, then what happened is Dr. Yakin came to the rescue again and said, wait a minute, everybody. We got to make this simple enough that everybody can communicate. We got to make it simple enough for clinicians and not so onerous for families, but we have to be able to make it in a way that everybody can understand it. So what's the universal symbol that we can use? Well, we just use the authenticated and dedicated gene name. And what we do is to maintain the CDG identity, we give the name of the gene and dash CDG. So that sort of puts it in our family. Well, once you do that, you can see that all of these different things that have been called CDG1B, 1C, 1D, and all these other ones can now have a similar designation. We just use that gene name and follow it with CDG. Well, that worked out pretty well, and that was published in the Journal of Inherited Metabolic Disease. Well, that's a journal that physicians read. But remember, we've got to get across to the other folks out there, the scientists. They've got to be able to sign into that too. So could we keep everybody happy? Well, do they like that idea? You know, because the scientists, the basic scientists are probably the best ones to be able to at least find the fundamentals that can lead to treatments. And if they're siloed from physicians and families, they're only going to get part of the picture. So we have to integrate the basic scientist into this. So what happened? We also did a publication in a journal called BBA, Biochemica and Biophysica Acta. And that's a journal that basic scientists read. So now we could begin to get everybody together as part of this whole operation. And now, as you look at this, we have the, as you can see over here to the left, all of these different gene names are now giving the things you are familiar with. And you may also know them by the old names, but we prefer that people use these names because they're going to be much easier to translate for everybody. And so in the larger CDG biomedical community, scientists and physicians and CDG families and other family groups, information trackers can all use this universal language now to refer to each other. And I want to just for a second talk about other family groups, because it's conceivable that there are people who have, let's say, certain kinds of muscular dystrophy, don't think of themselves as CDG, but they are affected because they have glycosylation disorders. Well, they've been organized in their own community for a very long time. And yeah, it's incidental to them that they may be CDGs, but they already have their group identified. They already know who they are, and they're pretty happy with it. And so we may, from our perspective, include them in CDG, but from their perspective, they may have their own group. Another example of this may be galactosemia, where that is certainly a well-established patient group. And it also affects glycosylation. So there are a number of different disorders that we may have to know about, incorporate. And as scientists, it helps us think more broadly about what the situation can be and where we can learn from each other and how we can share information. So in the end, to benefit the patients, all the stakeholders have to speak a common language. And we believe that the best solution is the current one, where we give the gene name and then call it CDG. So welcome to the club, welcome to the family. And I'm going to stop now. And I hope to be giving this in person. And because I will be, we can have questions later. All right, thank you.